Hello everyone, this is the video for 3.7 factoring practice. If you have not already done 3.5 and 3.6, if you have me for algebra and enrichment, I would suggest you go back and watch those videos and do those practice problems before starting this one today. Today I wanted to go back to factoring. Yesterday we only looked at identifying roots from the factored form, and you guys did really well with that. Today I wanted to go back to factoring, but start on one type. So instead of seeing some with positives and some with negatives and some with positives and negatives, today we're just going to look at all positives. We're going to practice that for a couple days, and then we'll go back to the other types. Okay, so just breaking it down a little bit more, and hopefully that's helpful for you. Remember that I am available all day, so email me. Send me a message. We can do a video call together for tutoring. So don't sit without at least trying to understand and trying to reach out to ask questions if you need that. Okay, so let's jump right in here. Example number 1 is x squared plus 12x plus 27. So this is in standard form. We don't have any parentheses. This is standard form of a quadratic function. It's quadratic because it has this x squared term right here. And we set it equal to 0 because we used factoring to find roots of our quadratic function. And remember, roots are where the graph crosses or touches the x-axis, and in those situations our roots are always going to have an ordered pair that has an x value, and then the y value is always going to be 0. So instead of saying x squared plus 12x plus 27 equals y, now we're plugging something in for y. That what we're plugging in is 0. And then we're trying to figure out what x equals when y is 0. Okay, so our ending product is going to be two factors that multiply together to get this. So we're going to have two things multiply together to get this. Just like we can take 6 and we can make it into 2 times 3, like that. Those would be factors of 6, things that multiply to get 6, or 7 could be written as 1 times 7, like that. Now we want to figure out, I know that this is an algebraic expression, but still we can break it down in such a way that we have two things that multiply to get it. And so that is our goal today. One way in the Monday video that I showed you how to do it, and this is my favorite way that I like to use, is called the box method. So the box method is thinking, okay, if I have a box or a square, this square has some area, and that area is made by multiplying the length times the width. So we make this piece, our function, be the area, and we fill that into 4 different segments. And then that helps us figure out the length and the width, the dimensions of this square. Okay, so we need to take our function and put it into these different sections that combine together are the area of this square. Then that again helps us figure out the dimensions. So I told you on Monday, this first term, x squared, is always going to go in our first box. The last number is always going to go in our last box. Then we have 2 boxes left and we have 1 term left. But this term can actually be pulled apart into pieces. So we have 12 total of something. We've got to figure out to put it into 2 different groups. So we've got to split 12 into two groups. They may have an even amount, like 6 and 6 in each, or they might have 10 and 2 in each. So we've got to figure that out. And the way that we figure that out is to think what numbers or what two numbers would multiply to get 27 that add together to get 12. Two numbers, they multiply to get 27 and they add together to get 12. So let's write that out real quick. Some number times another number equals 27. Some number plus that other number equals 12. So we've got to figure out what these two numbers are. Okay, so to do that, we want to make a little list. And first, just things that meet this criteria. Numbers that multiply together to get 27. Okay, so the way that I like to think about this is, okay, let me just start with 1. 1 times what equals 27? That's 27. 2. Does anything multiply by 2 to get 27? No, 27 is an odd number, so no. Next, 3. What multiplies by 3 to get 27? That is 9. 4, does it go into 27? No. 5, no. 6, no. 7, no. 8, no. 9, yes, but we already have it there. 10, 11, 12, 13, 14, nope. So we have all of our factors, all of our pairs of numbers that multiply together to get 27. Then, from this list, this is what multiplies to get 27. From this list, I want to choose, okay, which of these add to get 12? Which of these add to get 12? They both multiply to get 27, but only one of them will add to get 12. And you're probably thinking it is 3 and 9. 3 plus 9 is 12. 3 times 9 is 27. So I'm going to take 12x and now I'm going to split it into two groups. 3 of those x's are going to be here and 9 x's are going to be here. It doesn't matter which one I put them in. So I could have put 9x at the top and 3x on the bottom. That is not matter. That is not matter. Yeah, that does not matter. And now this will help me get my factors. So this represents the area, and I've got to fill in the dimensions here. Now, I didn't leave myself a lot of room on my paper, so I'm going to do this off to the side. So what multiplies to get x squared? That's going to be x and x. What multiplied to get that 27? That's going to be our 9 and 3. Plus 3 and plus 9. Now we have our factors. And so now we can find our roots. Our roots are going to be whatever makes this equation true. So if this whole thing is going to multiply together to get 0, either the x plus 3 part has to equal 0 or the x plus 9 part has to be equal to 0. And so we set those two pieces equal to 0 because the only way we get 0 by multiplying is to multiply by 0. So subtracting 3 from both sides, we get x equals negative 3. Subtracting 9 from both sides, we get x equals negative 9. So on my graph, my curve would go through the x-axis at negative 3 and negative 9. All right, let's do another example. We have x squared plus 9x plus 8 equals 0. My x squared term is going to go in the first box. My 8 is going to go in the last box. Now I've got to figure out how do I split up 9x into these two pieces. So I'm going to make a list. What multiplies together to get 8? Well, again, start with 1. 1 times 8 is 8. So that's my first pair of factors. Then I go to 2. What times 2 equals 8? That's going to be 4. Right, then I think about 3. 3 doesn't go into 8. 4 goes into 8, but I've already got it. 5 doesn't go to 8. 6 doesn't go into 8. 7 doesn't go into 8. 8 goes into 8, but I already got it. And that's it. So then I have to ask myself, of these pairs that multiply together to get 8, which of them add together to get 9? Is 1 plus 8 equal to 9, or 2 plus 4 equal to 9? If it helps you, go ahead and add those together and write it down, so then you can compare and see. But it may just stick out to you, and if you thought 1 and 8, you are correct. So I'm going to split this into 1x and 8x. All right, so now we have to figure out our dimensions. And so this works like a table of values. We have rows and columns. So whatever goes here on these pieces have to multiply to get x squared. That's always going to be x and x. And our last numbers on each side are going to be those numbers we chose of how we split up the x values. So plus 1 and plus 8. So putting that all together, we end up with x plus 1 times x plus 8 equals 0. If you're already sure, you can jump on to the roots without, setting up your equations. So what makes this equal to 0? That's going to be -1. What makes this equal to 0? That equals -8. So those are my 2 roots. I'm now going to stop this video. If you feel like you're ready from those 2 examples, you can go ahead and start the 3.7 individual practice. In the next video today, I'll do these next 2 examples for you.